by enabling digital adoption and integration of technologies for target value design. We are headquartered at Bengaluru, India, and also we are operating from 3 major cities in India. Those are Chennai, Hubli, and Hyderabad. We also have our European headquarters in Stockholm. We are serving our clients across the globe. This part is the USP of Desapex. I feel very, very proud to say that we are the first company in the world and only company in India to have the Sky Mark from the British Standard Institute, which is a global standard for BIM, and it is also ISO 19650 Part 1 and Part 2. Under the very strong leadership of Srinidhi Hungar and Varun Kumar Sagarkar, we have our young, passionate team of civil, mechanical, architecture, and electrical BIM engineers. These are some of the customer segments which we are serving, starting from hotels and restaurants, corporate real estate, residential, educational institutes, data centers, metro railway, logistics and warehouse, factory buildings, retail and infrastructure. So wherever there is a capital expenditure and operational expenditure involved, we provide digital solutions over there. I would like to brief you about the digital solutions that we are providing to our clients, which are the 3 verticals of Desapex. So the 3 verticals are digital design management, digital project management, and digital asset management. Under digital design management, we provide the solutions for clash detection and coordination, including architectural, structural, mechanical, electrical, plumbing, and firefighting modeling, and also BIM-based pre-construction services. At Desapex, we provide our clients to translate the conventional 2D drawing into 3D BIM models and perform these simulations before we even go to the construction site. So under the digital project management, we are providing to our clients to manage their construction projects digitally, where we provide a digital information delivery plan, technical due diligence, and setting up a buffer digital lab. Digital asset management, we assist our clients to digitize their project document in terms of the latest as-built 2D drawings into 3D BIM models. And we also digitize the existing physical buildings like the building after the handover stage or during the operational stage. So these are the graphical representation of the services that I just explained. This is digital design management. This is digital project management. This is digital asset management. This is something which is related to today's webinar topic. We are partnered with a Finnish company, Gronlund, which provides an integrated tool called as a Gronlund Manger, which is used to provide the solutions like BIM for facility management, in which we provide maintenance management, energy management, asset management, and also real estate portfolio management services using the BIM model. Why is there a requirement of as-built data? First and foremost step in digitalization is having an as-built data. First, if we consider most of the buildings down 6 to 8 years of handover, there will be many retrofittings which have taken place both in interiors as well as building services, but it will not be captured accurately. Second, the CAD and the PDF layouts will be either outdated or will not be updated with technical details. And during the construction phases, there will be deviation from the design layouts due to site constraints. Also, due to multiple building services, there will be lack of clarity and poor visibility. So most of the asset data is either in printed hard copies or Excel sheets, which is definitely difficult to use and of course time consuming too. Here, as-built models play an important role in creating digital twins. When as-built BIM models are integrated with CMMS solutions, we can visualize the conditions and track maintenance activities with associated technical data. Now, how do we create the as-built BIM model? First, we plan the site, where our team visit the site and analyze the conditions. They scan the points are decided based on the density of building services, type of building, and of course, interiors. Then we scan the building. We fix the scanners at the scan points and undertake scanning. Each scan point usually takes 5 to 6 minutes, also depends on the scan settings. Third, we process the data. So once the scanning is done, individual scan points are attached together to make a 3D model. Then we publish the data. The data is exported in suitable file formats and then imported to BIM modeling softwares. From those BIM model creation and based on the point cloud data, BIM models are developed and technical assets are created. Model enrichment with data asset data, the asset details are captured and of course collected from the site, and then we enrich those asset data in Cobie file formats. Cobie data input to BIM models. Here we have the instance and type parameters where we input the data and later can be exported to Cobie format. Here we have an example of how it can be exported from Revit, and also if you have other parameters too, it can be mapped before export. So as I already mentioned earlier in my presentation that we have partnered with the Finnish company Gronlund to offer BIM for facility management. So Gronlund Manger is a cloud-based CMMS solution and energy management software. It works as a SaaS model and doesn't require any specialized software or hardware. How BIM models are brought to GM. GM is the Gronlund Manger. Cobie exported from BIM models is brought to Gronlund Manger, and the data associated to BIM models, IoT or BMS data, can also be integrated to the solution via API integrations. Here we can see an example on BIM for facility management. If you can click on any of the asset, we can get to know its tech data and maintenance tasks history as well. And also we have an example on the digital twin. If you click on the spaces, we can get to know the temperature, the CO2 level and RH level, and the service requests raised on the particular spaces. And we can also analyze the data. So on the next slide, this is a small video that I have for you, which will give you a brief idea of how this Gronlund Manger tool works. Once we have all the required parameters, we can export the Cobie file. We can modify, add information required for the facility management. The file is imported to Gronlund Manger with all the information required. We can share, approve, update the data accordingly. Once it is updated and approved, it will be imported to the GM software. Selecting all the assets will give us the technical data like model number, serial number, location of the asset, etc., etc. So what you are seeing is a virtual model with linked assets. So upon selecting an asset, we can see all the maintenance task history associated along with the associated tech data. So this is a small video for everybody to understand how this tool works and what are its benefits. Now, I would like to introduce you all to Veikko, who has joined us from Finland. So he's the head of international operations in Gronlund, and he will run you through the Gronlund Manger tool, which will help you to understand the tool better. So Veikko, over to you.
Thank you, Richa. I will start to first share my screen Can you see it now?
Yes.
Okay. So good afternoon, everyone, and greetings from chilly Helsinki. It was actually 2 centigrades this morning, and warm thank you to all of you joining this webinar, and thank you, Richa and Desapex, for this invitation. My name is Veikko Martiskainen from Gronlund. Currently, I'm the head of our international operations and also partner in Gronlund. I have nearly 30 years experience of property softwares and also consultation. So everything I will have in my presentation are my experiences of this business and how we have helped our customers to improve their operations in properties. I'm actually very excited to have this honor and great opportunities to share my insights, how to increase property value using digital twins. And I truly wish you all will enjoy and find this webinar most beneficial to you. Okay, today we are online, but I promise to come to India again very soon, and hopefully I will have the chance to meet many of you in person, and we can continue the conversations. So in the first part, Richard did show kind of Desapex approach, how to digitalize and what is the digital life cycle of properties. This is actually one of the main drivers in our business, in Gronlund's business, and we actually share very much the same values, Gronlund and Desapex. We at Gronlund are very amazed of the technical skills and capabilities that Desapex has, and we are planning much closer collaboration in near future. But to start with, I would like to give you a little bit information of Gronlund and its background. So we are more than 6 years old company coming from Finland, currently having 1,300 employees, revenue more than 100 million.
Veikko, I'm so sorry to interrupt you in between your presentation, but it would be great if you can just share the screen.
Yeah, okay, it's not showing. Let me try again. How about now?
Yes, we can see it. Yes.
Okay, good. Sorry for that. Okay, so since the day one, innovation and development has been in the core of Gronlund's business, and we put actually 6 to 7% of our revenue to R&D type of issues. The main core, the backbone of the company origin is in mechanical planning, design, real estate, and energy consultation. And then the software is pretty much our international spearhead. So in that sense, we are, like Desapex, also very familiar with BIM models and how to utilize. And as I mentioned, like the digital life cycle of data is something that we want to achieve with our customers. And to continue with this, to move ahead towards today's topic, what we want to do with Gronlund Manager is property maintenance made smart and simple. So Gronlund Manager is a cloud-based property maintenance and energy management software. We've done more than 60,000 implementations in more than 30 countries. And in a nutshell, what the solution does, it gives control of property maintenance on a single digital platform. And again, this helps property owners and operators to create smarter ways of working, as well as saving costs and energy. And again, very essential in this part is the data, reliable data, because this helps you to make these wise decisions and add value to your properties and core business. I'd like to start with kind of like this cost side. So we can say that our solution Gronlund Manager helps building owners and operators to increase property value as well as saving cost and energy by giving the visibility and control of maintenance and energy. Everyone are interested in kind of like the savings part, so that's why I will kind of like start here. But kind of the question that where I would like to start with is kind of like these building related costs. Here, in a nutshell, is the main elements where the operational cost of properties come from. And we can say that up to 80% of the operational cost comes from facility management, kind of like the manpower and the services, equipment, and your utility costs. And this is actually where we focus with Gronlund Manger. Then when working with clients, often they ask that how much can I save? But kind of when taking the approach to savings, first we need to identify what is the saving potential and what are your costs. We usually find out that property owners and operators, they don't really know what are their operational costs, manpower, labor costs, equipment repairs, utility costs, what are the future needs for investments. And again, this comes to data. If you don't have the reliable data and you don't know what your costs are, it's quite challenging to define what is your saving potential. But from our experience, that what is it that you could save? So if you imagine that if you would say have 30% lower energy consumption, 50% faster service time on kind of like your repairs and ticketing, 60% less ad hoc repairs, 40% higher workflow efficiency on your maintenance operations, 60% higher technical operability, 50% longer asset life cycle, and no time wasted to search and compile the data. And you would have reliable data supporting your decision making. Of course, you would save quite a lot and also get all the benefits. And what is essential in this is the data. Why data has better idea to support your decision making. It's not only the kind of like technical aspect that affects on your cost and property value. So if you take another type of approach, that when you have well-maintained and operating properties, it affects on your lease level. That what would it do to your property value and your lease level if you would have kind of property value and core business? If you would have, for example, 10% higher or lower leases from tenants, or increase labor productivity, because operative properties, good indoor air quality, clearly affects the efficiency of your kind of like the people working in the properties. And again, in long term, it affects the technical value of the property. So if the value of the property would be 10% higher or lower, it will have in a bigger building portfolio significant effects. And we can say that in many cases, the saving potential, both to operational costs, is up to 20 to 30%, as well as for the technical value of the properties. So this is where we want to focus and affect. Then if we start with what are the kind of like main top property management challenges that we have faced, I have divided this in 4 different segments. Let's start with operational and cost efficiency. Property managers, facility managers, in fact, in property management and facility management, there's continuous pressure to lower the additional costs. How to manage the services, preventive, reactive maintenance, and other facility services. Improve technical operability and performance and safety of the properties. Then next segment is information management. Quite often we face that processes are manual, or you might have just Excel spreadsheets, and you can imagine that if you have big building portfolios, kind of like compiling the data from different Excels is a disaster. So data is missing, scattered, and difficult to compile. And because of this, there is poor visibility and low control. Energy and environmental responsibility is important. How to reduce cost and carbon footprint, how to improve energy efficiency and sustainability. And usually there is no up-to-date or reliable consolidated data available. This is very much in our home market where the focus is currently because of the kind of like EU regulation. There's these ESG standards and taxonomy is coming. So this is tightening very much, and corporates are looking ways of how to be more sustainable. Then in the end, there is the end user satisfaction and well-being. This, I would say, is maybe the most important, because actually in the end users of the buildings, they are the ones who are paying kind of like our bills. How to ensure the good indoor air quality, how to ensure uninterrupted working in environment, whatever the business might be there, and how to communicate, respond, and solve these kind of like end user needs. So much of the top property management challenges comes from these issues, and I think that you might share the same idea that if I would ask you that, do you think that all these 4 segments are well in your hands? You have all the data available and processes and tools to manage this. I would imagine that pretty much everyone would say that yes, there is something to improve. Then if you take a look of Gronlund Manger solution, it is modular software, and we have quite comprehensive and holistic approach towards properties. And if you think, for example, like energy management, how to save energy in properties, it is actually all these kind of like modules that needs to be engaged. In this slide, I will focus on energy optimization part, and saying that energy optimization is a continuous process. Usually, when people want to save energy, there's 2 approaches. You set up energy monitoring, and then you start to meter. Okay, that is the first step, but we can say that energy monitoring doesn't save you any energy. It gives you the idea how much you consume, where the consumption is, what is the trend, is it going up or down or being steady. Or the other approach would be investing in new technology, which is more energy efficient. But to save energy in long term is actually a process where you need to have kind of like all these segments in place. First of all, it forms of your daily operations, how you run your properties, how you use your BMS systems. Also, you need to have preventive maintenance in place, how you do your kind of like checking, cleaning, fixings, etc. And thirdly, you need to have your long-term planning, kind of like CapEx planning, where and when to invest to more energy efficient technology. And to manage this in the long term, you need to have the process how to operate. That's more like management. Then you need to have action. Someone needs to take action, because energy savings is not that some technology or some systems does automatically. Only way to do that is to do actions. Daily operations, preventive maintenance, and long-term planning. And to manage all this, you need efficient tools like Gronlund Manger. And then energy monitoring is kind of like one part of this very essential part, but it only doesn't help you. It's not the solution. It doesn't save you any energy. You need to have more holistic approach to energy savings. And that's why when I did show what is the total approach, for example, to energy saving, we have these modules, and together with this solution, we have quite good track record of having customers being able to save their operational cost and energy cost in a long term. Okay, let's continue. The topic was increasing property value using digital twin. Then how is digital twin related to all of this? This is one picture that illustrates this. On the left-hand side, we have properties. We have customer that might have one or several properties. Usually our customers, they have several properties. And actually, the previous part that Richard did show was very much related to this part here in the presentation, BIM to FM side, very much simplified. So actually, properties, they generate you the data, whether it's BIM data or kind of like IoT data. And then we have the CAFM or CMMS solution where you have the operations. But I have this building analytics layer down here, and this would be actually the digital twin part. That this is the digital replica of your properties. And then on top of it is integrated Gronlund Manger solution where you have the processes. So we want to utilize the information coming from the properties, kind of like static information, dynamic information, and integrate it with the CMMS system. So Gronlund Manger Digital Twin, it visualizes data from various static and dynamic inputs into one consolidated view. So information that we utilize is the BIM model, which is in many cases produced, for example, by Desapex. Also the device information, all the technical data, but also measured dynamic data from sensors, BMS system, or IoT systems, as well as integrating the facility management maintenance events into the digital twin model. Okay, I want to try to make this more concretical by sharing some of the use cases. Okay, this first use case, digital handover. This is actually the video that Richard did show you, so I will not go into that because it's already shown. So this is where it starts, kind of like when you have property, project, you have design, you want to utilize that as a setup for the digital twin. So, well, once the information is there, we can do, for example, different type of zone visualizations like ventilation or cooling, lighting areas. So that if you have fault in some area, you can easily detect that, okay, if there's problem with cooling or ventilation, which is the air handling unit, chiller, or electrical distribution box board that is providing you the electricity or services. These zones, you can define any zones, for example, tenant areas, different type of spaces. There is no limitation to that. Then there is the preventive maintenance and maintenance events. So we make the annual maintenance PPM that you can monitor, kind of like what is the annual calendar, whether the tasks are done, but these can be illustrated also in the digital twin. So you can follow up checking the assets, that what are the maintenance actions carried out, or what is the technical data, what are the coming maintenance actions. Also, for the ticketing, we can make, for example, QR codes on different spaces, and you can monitor that where you have open tickets, which are the spaces where you have most tickets, are they open or completed. And how this happens is on the left-hand side, we can see this video. Unfortunately, the picture is quite small, but when there's QR code, you just take your mobile phone, you read the QR code, and then you can add the information. You can also take picture what is wrong there, and then the work order is submitted, and it pops up in the BIM digital twin model that where is the new work order located. Easy and simple as that. Automated maintenance. This is actually how we utilize, how we make even faster the service request process. So if there are systems or smart sensors that can automatically detect kind of like the deviation, we can utilize this information, and it creates the work order automatically for the maintenance. So we don't need manual process there, and the reaction is immediate. And then maintenance people, they can kind of like take the work order on the mobile app while they are on the go. So this makes the process much more faster and transparent. Also, we can utilize the data for building analytics. Actually, we have built up algorithms in our solution that usually we utilize BMS data, and the algorithms set into the system define kind of like how well the property is working according to the set targets. And it gives you kind of like the list of most faulty systems. So here we can see that air handling unit 01 is most faulty, like the score is 0, that it's not working at all according to the set target. So this makes it easier for the maintenance to detect and react that, hey, something is wrong with this air handling unit, now we need to do the fixing. So this converts the maintenance not only from reactive maintenance or preventive maintenance towards predictive maintenance. This is something new that we are bringing in to the market, how we can utilize these BIM models in augmented reality. In this video, we start with work order that you read the QR code, you can make the work order. Sorry, there's some video music on the background. We create the work order very much similarly as in the previous use case. Then with this AR tool, when the maintenance comes, as you can see, they can scan kind of like the location. There is this virtual token that read it, and then you can highlight the BIM model, the technical model, this ventilation model, and you can view kind of like along the ceiling, how the ducts go. This can be integrated also to the BMS system so that you can view the information of what are the temperatures and whatever the data is from BMS system. Also, there's indoor navigation if there are work orders that this would lead you where the kind of like maintenance action is. You can read, you can see that, okay, there's open service request, you can do the work, and you can mark the work as completed. You can also view the list of kind of like what is the next work order that you have on the list, and then continue towards the place where the work order has been kind of like created. So this is still on a more like pilot phase, experimental phase, but we have done like this one, the first customer deliveries already. Next use case would be energy and energy metering, how to compile, monitor, control the energy data. Gronlund is not hardware company, but we can also provide meters and kind of like the metering system to our clients. And this is also something that we collaborate with Desapex. So Desapex has the capability of providing meters for the property, how to collect the data, not only the energy and water data, but also we can collect indoor air quality information. For example, this report shows normal office hour profile on daily basis. Monday to Friday, you can see the consumption level lower on the weekends, and darker part indicating the nighttime consumption. So it's quite easy to detect kind of if there are profile deviations and then to react. Then to take a little bit bigger, wider approach for business intelligence type of reporting, which is something that we can customize according to the customer needs. Because in many cases, customers, they have their specific targets, goals, and if you have only standard reporting, it's not comprehensive enough to meet these targets. So reporting needs to be customized according to the set targets of our customers. And of course, the kind of like needs to modify the reports, they vary and they change over certain time periods. So you need to be able to be quite agile. But with these reports, we can quite easily illustrate data coming from big amount of properties. So in this example, each dot represents one property, indicating how big the absolute consumption is, how big is the relative consumption, like kilowatts per square feet, and whether the consumption is going up or down. So it's quite easy to get the picture and to understand where we need to follow up. Or the reports can be related to ticketing process, service reactions, that whether your process and the actions meet the SLAs or not. So these were few examples that what we have done and provided for our customers. I'd like to, in the last part, I would like to share a few customer cases that I've been working with. Actually, our solution, Gronlund Manger, it is suitable for all type of properties. We have customers coming from all these different segments. So it doesn't matter whether it is hospitals, investors, office buildings, retail, industrial. We have customers coming from all these segments. This first case is from Abu Dhabi. Their benefit is that they are using Gronlund Manger for their maintenance services, and they have managed to get 50% saving in their service time. So much smoother and faster process, being able to follow up their SLAs. And actually what we are doing in the next phase is making this process more smart. So the sites that they are doing the maintenance, there will be sensors, or there is actually sensors and systems that can automatically provide the information that there is malfunction. So we will automate the ticketing process. Also, we have created the first BIM models together with Desapex, and we will be providing these sensors and meters for their cases. So first they have digitalized their maintenance operations, and now they are digitalizing the data flow and bringing in sensors and digital twins to their customer base. One of our biggest customers is Senat Properties from Finland. It is governmental property owner. We have collaborated with them for 25 years now, and some years ago they had the aim for 100 million euro annual savings. And what is their approach to this is very much digitalization. They see that digitalization is the way how they can get all the savings. Of course, not all the savings are coming from Gronlund Manger, but it is very comprehensive approach, utilizing digital twins, building analytics, maintenance processes, energy monitoring, bringing in also AR, artificial intelligence and machine learning to analyze the data, how to improve energy efficiency and continuously improve their ways of working. This case is with universities. Actually, the video that I did show of the AR tool is one of the university properties. So they are very advanced in this, and they have practically utilized everything that Gronlund Manger has, starting from maintenance, building analytics, utilizing IoT, now bringing in digital twins, utilizing this information to improve energy efficiency, indoor air quality, and their cost efficiency. With these universities, we have helping them together. We have helped them to achieve annual energy savings of 3.5 million euros annually. The last case comes from healthcare segment. This Uuskiinteistöt, it is the hospital properties having 1 million square meters of hospital properties, which would be equivalent to 10 million square feet. And also they are utilizing, like we did show the first video from design project, how the data flows to facility management. So they have already implemented this process, and whenever they have the changes in their properties projects, they use this Gronlund Designer tool, and the data is imported to Gronlund Manger. Also, hospitals are very big energy consumers, so they have implemented pretty much the same features, functionalities, and operations as in the previous cases that I did present. Their savings were 1.4 million annually, and kind of like when we started this type of collaboration, this was kind of this index of hospital properties that they were in a path of very strong cost expansion. Costs were increasing, and they managed very much to cut down the curve that way they were on. So this was my part of it. Thank you for listening. Now back to you, Richa.
Thank you, Echo, for sharing all the valuable insights. So we'll open the question poll. If anybody has any question regarding anything, you can drop all your questions in the chat box. So Veko, we have one question from Abina. How many sensors are required for a residential building?
I would say that it depends on your aims and goals. For example, residential buildings, I would say that the approach is either you have those on room basis, or you might have just one. Depends on kind of like the size. But basically, first you need to define your requirements. What are you trying to achieve? And then we need to build up a technical solution that will fit into these needs.
Thank you, Veko. So we have two more questions. Will digital twin process can be used for property validation for banking process?
You mean properties where the business is banking? Is this the question? So if this is the question, I would say that this is not limited to any type of properties. So yes, definitely.
Thank you. Veko, we have another question from Abina. Are this system able to monitor and act according to extreme events such as floods or any natural hazards?
Well, we are more focusing on the properties inside, but of course, if there are extreme weather conditions and if you have systems in the properties and the weather causes like alarms in the property, these extreme conditions, then this gives you the idea that, hey, now we need to do something there. But to kind of like forecast these type of incidents, maybe not yet. Okay. The question there I can see now was for bank loan process. Something that we have actually used digital twins is when we do the scanning, then we are capable of defining the value of the property in more efficient way, kind of like what is the technical value of the property, and if there is transaction or if there's a need to define that what is the value of the property, or you are doing transaction. In these cases, we have already used digital twins, but it's not more kind of like property management related, but to define the technical value of the property and give the idea. So in that sense, the data that digital twin can provide can be used for kind of like this type of. Do we have any more questions?
So I think we don't have any more questions, Reko. I would like to thank you and all our attendees who have joined us for today's webinar. Stay tuned with us at all social platforms and of course LinkedIn. Thank you so much.
Thank you very much. Bye-bye.
Bye-bye.